Hello students, this video intends to help aid in your understanding of the subtraction rule as it is presented in the Stat 1040 and 1045 classes. Within this video, we will touch on objectives 4.1 and 4.5 of Unit 4. We will be covering the concepts shown on screen. After some explanation, you will have a chance to practice these concepts at the end of the video. Let's get started. We will begin by defining what the subtraction rule is, and then continue our learning by exploring some examples and practice problems. The subtraction rule can be represented by the following equation. Probability of event A is equal to 1 minus the probability of the opposite of event A. In this equation, we are essentially trying to exclude events that won't get us a success. Hence, you may also hear the subtraction rule referred to as the exclusion rule. We are subtracting by 1 to represent every possible outcome in the situation. If you would rather work with percentages, this 1 would instead be 100%. Remember, probability can only range from 0 to 1 or 0% to 100% to represent the chance that something either will not happen or will happen. The key words of at least one and not all indicate that we will need to use the subtraction rule. These keywords also have corresponding words for their opposite events, those being all for not all and none for at least one. It's highly worth your time to memorize these terms as well as their opposites in order to make the problem-solving process more streamlined as you practice. Let's work through this example together to get the hang of this rule. Take a moment to read over the text below. As usual, begin by searching for keywords within the problem. The previous slide informs us that at least one lets us know to use the subtraction rule. Let's set up our equation and then begin filling in values. So, what is the probabilities we're looking for? Our problem wants us to find the chance of rolling at least one 4 within 3 rolls. As also informed by the previous slide, the opposite event of at least one is none, aka no 4s rolled. Now that we have written everything out, we can begin substituting in actual numbers. The probability of rolling a 4 on a 6-sided die is 1 out of 6. Therefore, there is a 5 out of 6 chance to roll any number besides a 4. We will multiply 5 over 6 by itself 3 times, since we also must observe the independent multiplication rule, as we are rolling this dice 3 times. Now, all that's left to do is solve. When we multiply 5 over 6 by itself 3 times and then subtract that value from 1, we get an answer of 91 over 216. Now that we have reviewed the subtraction rule, let's do some practice to check our understanding. Problem number 1. A gardener is selecting which seeds to plant for the upcoming season and has decided to leave which seed packets she chooses up to chance. In a box, she has 3 tomato seeds, 5 strawberry seeds, 4 rosemary seeds, and 7 basil seeds. From this box, she will pick 5 seeds to plant. Question 1. What is the chance that of the 5 seeds she picks, not all of them are basil? Pause to answer and then press play to check your work. Answer. The probability of not all basil is equal to 1 minus 7 over 19 times 6 over 18 times 5 over 17 times 4 over 16 times 3 over 15. Remember, the opposite event of not all is all. To solve for our answer, we must exclude the chance of selecting all basil. Furthermore, since we are taking the seeds out, we must observe dependent multiplication in this problem. This is why we are changing our numerator, which represents the number of basil seeds, as well as the denominator, which represents the number of total seeds in the box. Question 2. What is the chance that at least one of the seeds she picks is for a strawberry plant? Pause to answer and then press play to check your work. Answer. Probability of at least one strawberry is equal to 1 minus 14 over 19 times 13 over 18 times 12 over 17 times 11 over 16 times 10 over 15. The opposite event of at least one is none, and thus in this problem we should exclude the chance of picking no strawberries. Like the previous problem, we also must observe the dependent multiplication rule within this problem. Problem number 2. A carnival game has a spinner which, when spun, determines your prize based on what color and combination you get after spinning 3 times. There are 2 yellow spaces, 5 green, 1 blue, and 2 purple. Question. What is the chance that you get at least 1 purple within your 3 spins? Pause to answer and then press play to check your work. Answer. probability of at least one purple is equal to 1 minus 8 over 10 times 8 over 10 times 8 over 10. Since the opposite of at least one purple is no purple, we must exclude the chance of spinning no purple in order to find our answer. Unlike the previous problems, since spinning the wheel means the outcomes of each spin are independent from each other, we use the independent multiplication rule here, and therefore do not change our numerators or denominators. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video was helpful, and remember that help is here if you need it.